So we're continuing with test 8, and we got to number 32. We're going to go through 32 on to question 51 on this video here. So number 32 says, because it's going to get a little bit, we went over mainly like questions where you have had true and false and, fill in the blank. But now we're going to have some questions that we're going to have to do some calculating in. So let's start for number 32. At 20 degrees centigrade, the rate of a particular reaction is 0.001 moles. What is the rate expected to be at 60 degrees centigrade, assuming all other factors remain the same? So for each, how many degrees does it double? So remember that? For each 10 degrees, it doubles. So you have 10 degrees, 20 degrees, or you start with 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees. So you're going to go up four times. So when you go up 10 degrees, it's going to double. So it'd be 0.002. Then you go up, that would be going up to 30 degrees. Now you go up to 40 degrees, and it's going to double that too, which would be 0.004. And so then you're going to go up to 50 degrees, and it's going to double, and that 0.004 is going to be 0.008. And so then you go up to 60 degrees, and that's where we want to be. You're going to double the 8, so it's going to be 0.016. So which one of these say 0.016? C does. See how it does? Basically every 10 degrees going up, it doubles. So it's going to be 0.016. C. Number 33. Two compartments labeled A and B are separated by a semi-permeable membrane. That's osmosis we're going to talk about here. So you have semi-permeable membrane lets some especially water, that usually lets the water come through, but doesn't let the other molecules. So semi means that some molecules can go through and others can't. So what happens if the compartment A is filled with honey? A solution of sugar dissolved in water. And compartment B is filled with distilled water. Well, honey is pretty thick. It's not going to go through any membrane, right? So the other one, B, is filled with water. Well, of course, the water is going to want to move in and dilute the honey through that membrane. So let's see which one. A, it says there is a net transfer of sugar from A to B. Sugar is not going to transfer from A to B. B, it says there is a net flow of water to A and B. What's A? A is honey and B is water. Well, the water is not going to flow from A, because it's already thick there. The water is going to want to flow from B to A to dilute the honey, right? So there is a net transfer of sugar. There's no transfer of sugar. And number D, there is a net flow of water from B to A. So it'd be D. The water that is going to dilute through the membrane and going to flow to the higher concentration of molecules, which is water will flow from B to A. So number 34, which statement best explains why the following reaction is not likely to occur in a single step? Okay, this is a pretty complex molecule, as we see, because it looks like it has two carbohydrates there. So you have 2 carbon 6, hydrogen 6 on a liquid, plus 15 oxygen, plus then you have 12 carbon dioxides and 6 H2Os. So if you count those up on the side here, you're going to have 17. So you have 17 molecules that are going to have to collide to be able to get this. Likely, can you do that in one step? Have all of a sudden one step 17 molecules just collide? You're going to have a bunch of steps, aren't you? So anyway, A says exothermic reactions typically require several steps. Well, there's no exothermic there at all. So B, gases do not usually react directly with liquids or solids. Gases can react with liquids and solids. So C, the 17 body collision required is extremely unlikely. That's why it has to have steps, because it's very unlikely for 17 bodies to all of a sudden bump and do it in one step. Maybe one atom will be able to do that, or two atoms, but not 17. So C would be right. The 17 body collision is extremely unlikely. The D says the reaction is spontaneous and not reversible. That has nothing to do with spontaneous or reversible. C would be the answer. Number 35. Which of the following terms describes a platinum mesh used to break down petroleum vapors into smaller molecules? So, what is this? What is this? It's a catalyst, right? Well, it says A, activated complex, B, homogeneous catalyst, C, heterogeneous catalyst, or D, enzyme. Well, it's going to be catalyst, but is it homogeneous or heterogeneous? Well, it's with a mesh there, used there with a metal, it's basically going to take more than two phases to do that. So homogeneous means you only have one thing affecting it. Any type of metal is going to require more than that, so it's going to be heterogeneous. Most catalysts are heterogeneous catalysts. They take more than one phase. Number 6, which of the following combination is most likely to be completely miscible? Means it completely dissolvable. Number 1, water and isopropyl alcohol. B, isopropyl alcohol and oil. C, water and oil. Okay, when we look, which one will dissolve in each other and be clear? Does water and oil dissolve in each other? No, it's not going to be C. Does isopropyl alcohol and oil? No, they don't dissolve, because alcohol and water are both nonpolar. So alcohol and water will dissolve in each other. So, but alcohol is not going to dissolve with oil, because alcohol is nonpolar, or alcohol is polar, and water is polar, so like and like. So it'd have to be A. You know that water and alcohol dissolve in each other. Which of the following is not necessarily true about the rate determining step of the reaction? The rate determining step is that rate, that slower rate, when you have a bunch of phases, and the slow one that takes the most time is going to be the rate determining, because it takes the most time, and it will determine the rate of it. Some of the reactions, the phases of the reaction happen real quick, and some take a long time, but it's the same phase. So A, the reaction can proceed no faster than the rate determining step. B, the rate determining step is the slowest step. Well, looking for the one that's not true, okay? The first one says the reaction can proceed no faster than the rate determining step. That is true. The rate determining step is the slowest step of the multi-step reaction. Yeah, that's true. Number C, the rate determining step involves the greatest number of reacting species. Does that say species? So the rate determining step involves the greatest number of reacting species. D, the rate determining step should be the focus of any attempt to increase the reaction rate. So it's going to either be C or D. I think the one that's not going to be is going to be C, the greatest number of reacting. See, I'm not even sure what that says, but anyway. But we know that the first two are true. So, which of the following substances would you expect to be most soluble in a nonpolar solvent such as gasoline? So, if you have a nonpolar solvent that's nonpolar, well, water says polar, so that's not going to dissolve well in water. Ammonia is polar, So it's not going to, nonpolar doesn't dissolve well, and because remember, like dissolves in like, so it won't dissolve well in ammonia. Paraffin is nonpolar, so of course it will dissolve well in nonpolar. So C would be your answer. Number 39, which of the following is not a colloid? Okay, an aerogel is A, B is milk, C is smoke, and D is sugar water. An aerogel definitely is a colloid. We studied the aerogels. Milk is a colloid because if you look at milk, there's, particles floating around the milk. That's what makes the milk white. It's a colloid. Smoke in the air is a colloid. You see through, it's smoke is suspended in the air with particles in the air. Sugar water, when you take sugar and you dissolve it in water, it's like a clear solution. So it would be D, sugar water. 40. When a solid is dissolved in a liquid solvent, does increasing the temperature tend to increase or decrease the solubility? So if you are increasing, so you have a solid and it's dissolved in the liquid, and then you increase the temperature, what's going to happen with the solubility? It's going to go faster. When you increase the temperature, then all of a sudden all these particles are going to collide more, and so so it's going to increase. So the solubility will be able to be soluble faster, would increase with the temperature. Number 41, when a gas is dissolved in a liquid solvent, does increasing the temperature tend to increase or decrease the solubility of the gas? So now we're talking about gas. So if we take gas, say you take a carbonated beverage like Coke, and you have gas in it, right? In your Coke. So if you increase the temperature, what happens? Well, if you increase the temperature, the solubility goes down, doesn't it? In that type of solution. So if you decrease the temperature, it will go up. So number 42, what term refers to a solution that contains more solute than is ordinarily possible under equilibrium? So when you have equilibrium, you're going to be saturated. But if you try to put more solute in it and it gets unstable, but you're forcing the solvent to come in, what do you call that? Super saturated, right? Super saturated. It's a super saturated solution. Number 43, does adding a non-volatile solid to a liquid tend to raise or to lower its boiling point? Well, this is pretty easy. So you have a boiling point and of water, and then you add a bunch of salt. Is that going to raise the boiling point so that it's going to take longer to do it? Yes, it will. It will raise the boiling point. So you could put raise there. So now the opposite is with the freezing. So you get a freezing point down here and you put salt on the ice or whatever, then it's going to lower, but as for the boiling point, it raises the boiling point. So the more, like you take salt water, it's going to get hotter because the boiling point is going to be higher. Raise it. Number 44, name the short-lived, unstable arrangement of atoms that our molecules are thought to form as they collide and chemically react. You call that the transition stage, because that's when, remember, you have that hill that it's going up. The top of the hill is the activated complex there, where it transitions into a new molecule, and then the rest that goes down so it's that state right there is that short-lived, unstable state where it's reacting to form a new thing. Okay. Number 45. What term refers to a substance that increases the rate of a chemical reaction without being consumed in the reaction? So we had a lot of these. So basically these are catalysts, and these catalysts actually make it so that the increases the rate of chemical reaction without being consumed. So the rate means it's going faster and faster and gets done faster, has more products because more of the atoms get to go to the end point. So it increases the rate of a reaction is called a catalyst. C-A-T-A-L-Y-S-T. Number 46. Does increasing temperature of a liquid tend to increase or to decrease the vapor pressure? So if you are increasing the temperature, is the vapor pressure is how many atoms are going to leave and it's going to into boil. So if you increase the temperature, it's going to increase the vapor pressure because more atoms are going to want to, it's boiling, then all of a sudden more steam's coming and more steam. So you've increased the vapor pressure. Number 47. Does adding a non-volatile solute, like putting salt, to a liquid tend to increase or decrease its vapor pressure? So first one is we increase the temperature. Now we're going to add salt to it. So if you're going to add a non-volatile to a liquid, does it tend to increase or decrease its vapor pressure? So basically the vapor pressure, I would say, would be increased. So number 48, calculate the molarity of a solution prepared by dissolving 80.0 or 8.0, let's see, 80.0 of hydrogen fluoride in water to make 500 milliliters of solution. The molarity mass of HF is 20.01. So you take this, I'm going to tell you how to do this. Get your pens out. So you're going to take that 80.0 grams, and you're going to divide it by the moles there. So that way you can get how many, what is the molarity, how many moles. So you take 80.0 divided by 20.1. Well, I would just round that off to 20. So you have 80 divided by 20. So 80 over 20, just put 80 over 20, which is a fraction, right? And that's 80 divided by 20. What's 80 divided by 20? 4, right? So 80 divided by 20, 20 times 4 is 80, so 4 moles. So you have 4 moles now. So now you have 4 moles and you have 500 milliliters. Well, how much is 500 milliliters? Because you have to always put it in liters. So you're going to change the 500 milliliters to 0.5 liters. So you're going to have 4 moles divided by 0.5 liters. So 4 divided by 4 moles divided by 0.5, what is that going to be? So as you move the decimal point, if you can do it on your calculator, what is it going to be on your calculator? So when I did it, let's see, 5 divided by, you're going to move that decimal point of 4 moles over. 5 goes into 40. How many times? 8. 8 times. So it's going to be 8 with a capital M, 8 times. 4 moles divided by 0.5 liters. Okay? A chemist needs to prepare 2.50 liters of a 0.0100 moles of ammonia. How much is 14.5 moles of concentrated? How much ammonia does he need? So in this equation, you are going to, you're going to be able to, first of all, the volume is going to be 2.5 liters, and you're going to times that because it says of a solution, so you're going to times that 2.5 by 0.01, which is just going to move the decimal over, really. 2.5 times 0.01, and then you're going to divide it by 14.5 moles. And so what are you going to get? So basically take 2.5 divided by 14.5. Do it on your calculator. Did you get about 0.017 liters? And then if it says they want to know how many milliliters, you just times that by 1,000 and you'll get 17 milliliters. Okay? So number 50, we're getting there, aren't we? Determine the freezing point of a solution containing 50 grams of sucrose dissolved in 750 grams of water, and round to the nearest 0.01 centigrade. The K for water is going to be 1.86, and the molar mass of sucrose is 342.3. So the first thing you're going to do is taking that 50 grams, and you're going to divide it by the molar mass, which is 342.3. So divide 50.0 grams divided by 342.3 grams, and you should get around, go ahead and do that, 0.346 moles. And then you're going to take that 3.46 moles and divide it by the kilograms of, or the grams of water, 750 grams of water, which you're going to have to turn to kilograms. So they're going to be 0.750 kilograms. Divide that out, and you should get 0.195. And then you're going to take that 0.195 and times it by the 1.86, and you're going to get 0.363 centigrades. And so then to find the temperature, you're going to say, okay, from 0, so it's going to be about negative 30.36 degrees. Okay, you can figure that out. This is a difficult one because it has a lot of steps. So go ahead and figure this one on your own, okay? I kind of gave you the way you're supposed to do it. So explain why a can of soft drink, okay, remember I went over this already with you. Explain why a can of soft drink would be expected to frizz more when opened at the peak of Mount Everest, which is 260 torr pressure, that's an atmospheric pressure, than when it's opened at sea level, which is 760 torrs, that's the pressure at sea level. So you got to explain why this happens. Well, one thing, it's Henry's law. So basically, Henry's law says that the higher pressure of a gas, the greater solubility of the gas. Just think that. Henry's law is the higher pressure of the gas is going to be the greater solubility. So the higher pressure, which one's the higher pressure? At sea level. So at sea level, that basically the gas, the carbon dioxide, is going to be more soluble, right? So more soluble means it's going to it's going to dissolve in it. But when it frizzes, it means it's not dissolving well, right? So the lower pressure of the carbon dioxide in your drink at the higher altitude is the lower pressure, makes the gas less soluble, and so the gas is going to be frizzier. So basically saying, you can write, under Henry's law, the higher the pressure of the gas, the higher the pressure of this gas, the greater solubility. So it's not going to be at the lower pressure of atmosphere, which is at the higher altitude. It's not going to be as soluble, right? And so it's going to be frizzier. So any way you want to put it there, you write it in your own words or however, and that's going to be the end of that test. So finished up on your test. So we'll get on to the last quiz and test in the next video.